Hello, everybody, and welcome to Math 201, Research Methods in Statistics. My name is Jonathan Earl, and I will be instructing for the duration of the course. For the time being, I guess, we can't meet in person. As far as I'm aware, we're doing this for this week and next week, and hopefully we'll be able to meet in person after that. Okay, so for the first class, what I want to do is just go through the syllabus. Then I want to go and give kind of I don't know, an overview, an introduction to some philosophy and history behind statistics, and then at the very end, I'll very briefly introduce the computer software package R. Okay, so we ideally will meet Monday nights from 6:30 to 9:30. We don't have a a reading week, but we will be off on the Family Day holiday in February, um, but not Easter Monday. Okay, and then assuming that we do end up eventually meeting in person, we'll be in room 212B. For the course, the two main things that you'll need will be the textbook, which is an introduction to statistical thinking with R without calculus, and it's readily available at this link. If for some reason you try to click on the link and it doesn't work, just copy paste it into your browser. And then we'll also need R. So you can download R. You can download R itself from this link, the CRAN-R website, or you can also download an IDE RStudio from here. So it'll give you the same kind of thing. They'll just look slightly different. For the most part, I'll probably just be using the standard R, which I have here in the background. But if you want to use RStudio, that's fine, and it shouldn't be a problem. Okay, so all of the important things that you need for the course I will post in Discovery, especially given that we won't be meeting for 2 weeks, so the important things will go there. And I'll probably somewhat routinely, I guess, post announcements in the Discovery page. Okay, so we have kind of a general overview of some of the topics that we'll be covering. So we'll be talking about statistics, probability, random variables, distributions, some particular kinds of distributions, so binomial, Poisson, normal distributions. We'll talk a bit about sampling, sampling distributions, uh, different kinds of estimation, so estimation of a point, and also some intervals. And then we'll talk about hypothesis testing, significance testing. Um, I will try and focus on some examples from life sciences, so maybe biology, physics, those kind of things. Um, for some other things, I'll probably do maybe some board game kind of examples. So things that involve dice rolls like Risk, maybe something like that, Monopoly, something like that. Um, as we get there, if there are, I don't know, particular environments that you would like to see examples from in particular, let me know and I will see what I can do about that. Okay. Let's see. So we have various kinds of, I guess, learning objectives that that we ideally will hit by the end of the course. Okay, so I guess the important thing for how we're going to grade things in the course. So we'll have a midterm, which I am planning on doing March the 1st. We'll have a final exam, we'll have some written homework, quizzes, and my hope is that we can have a project um, to allow you to kind of work out some of the various techniques that we'll pick up during the class. The main problem that we could end up having is just what the government allows us to do. Okay, so one of the main ways that we'll do things is we'll have some written homework. So what I'll do for these is maybe my plan is to every other week have a set of questions. I don't know, maybe we'll say 5 or 6 questions or so, depending, maybe a little longer, maybe a little shorter. Um, that will be over the relevant topics that we'll discuss. Um, okay, so quizzes. What I plan on doing with quizzes is giving out a set of, we'll say, 10 problems, something around there, that you get to work on throughout the week, and then I will pick one at the beginning of each class, and we'll go from there. So you get to work on the problems throughout the week, and if you have any questions about any of these problems, you can even ask me, for suggestions, um, about what you're working on. Okay, so tests. So one of the things that we have here is that I'm planning on making the midterm worth 14%. And the reason why I'm picking 14% is that my understanding is that if a test is worth at least 15%, we are supposed to use a lockdown browser or something equivalent. And my position is that I really don't like using those kinds of things. I find them a hassle to use. I find them um, just annoying. And I wouldn't like using them as a student, so I'm not going, or I'm going to do what I can to avoid forcing that on any of you. So to get around that, we'll just make the midterm worth 14%. Okay, and then the plan for the project is it's going to be somewhat in flux for the moment, but ideally what I would like to do is have, um, I guess, it somewhat open-ended in that you select a data set, so maybe something you have or maybe something that you would like to work on, and I would see what I could find for you. Um, and you try and answer some interesting questions. So you'd want to come up with an idea for a data set and some interesting questions to ask about that. Um, again, you might want to, whenever we get when we start thinking more about this, you might want to ask me if what you're proposing is a good idea. Um, just so that you don't start working on something that is going to kind of bog you down. um, at the end, I would like for everybody to be able to present their work, but again, this will be somewhat limited by the government structures that we have to operate under. Okay, office hours. I don't have anything. I don't have a time formally set. I'm mostly able to work off um, any scheduling constraints that all of you have to play with. Um, I guess that I would plan on doing something, maybe we'll say Tuesdays at 12 or so. Um, I might do maybe Tuesdays at 12, Fridays at 12, if that's okay for everybody. But I'm fairly flexible with this, and if for some, I don't know, if whatever time we come up with doesn't work, just send me an email and we can always set up a Zoom call or something like that. Okay, the easiest way to get in touch with me, especially with us not being able to meet in person, is just send me an email, and my email is up at the top, jearl@redeemer.ca. Okay, and then I've also gone and included some suggestions on, on how you can succeed. Um, then in addition to that, we have various notices on kind of procedural matters. Um, please do attend class, or I guess in this case, attend class by watching the video content. If we wind up meeting in class or such, please don't record the classes because, well, the university says you're not supposed to. Um, academic integrity, please don't cheat. If for some reason you have to miss a test, please get in contact with me as soon as we can and we'll make things work. Um, especially with the structures that we're going to have to be working under or with, I'm pretty understanding for any issues that you run into. So yeah, so if you have scheduling issues, just let me know and we'll make things work. Okay, and then we have a list of the learning services, the library, um, services, and counseling and such. And um, yeah, just the last part is the syllabus gives us kind of guidelines, and there might be some changes. So depending upon how things work with time, the schedule might vary a little bit. So I have a rough outline for a schedule that I want to work from. Um, Today I'm just going to do the first one. Um, So yeah, so my plan is to go through this introduction and then 5 other topics. Just because I have 5 topics doesn't necessarily mean I'm going to do this in 5 weeks. I might condense things a little bit. Um, because what I find with doing the videos is that I'm able to condense a lot of um, the course material down um, uh, just by doing it this way, we don't end up having any discussion, any live questions, anything like that. So the content kind of gets cut down a little bit, or the time required to go through the content gets cut down. So what I might end up doing is the um, if the time required to go and cut all of these topics down, or the time required to go through all these topics isn't that long, what I might do is go through all of these and then do um, a day or two kind of talking about some extra topics. So maybe some practical examples, some more higher level things, something like that. But we'll see as we get there. Okay. Okay. So if we're going to study statistics, the first thing that we might want to ask is, what is statistics? And the way the textbook goes and refers to statistics is it's a collection, analysis, interpretation, and presentation of data. Right? So some of the main takeaways from that is we have some collection of data. Usually numbers, not always numbers, could be something different, but usually numbers. And then we do some kind of um, we draw some kind of conclusions from our data. Or maybe we just um, present it, but presenting kind of to draw conclusions from the data. Okay, and then one of the other main um, terms that we come across is probability. Right? So from the textbook, the term probability is used to refer to a mathematical theory used to study uncertainty. There are various definitions of probability. This is one. What we'll see is that historically um, the definition and also the connotation around the word probability is kind of ebbed and flowed a bit. It's changed over time, had different meanings to different people, and that's one of the things I just want to go through today to give us kind of an appreciation for what we're going to be studying. Okay, so historically there have been a couple, or I guess a few, um, somewhat synonymous terms um, that have been in vogue historically. So the first traditional one that we have that really didn't start arising until I guess historically somewhat recently is probability. So to us, maybe probability has kind of this idea from the textbook. So we're studying um, something uncertain. But we could also look at it as the probability of something happening, or maybe the chance of something happening, which is where the second one comes in. So probability maybe is referring to um, likelihood of some event occurring, whereas chance kind of has the connotation of something that's um, less observable, less predictable, something maybe more unknown that we can't really grasp. Um, but I guess you could also think about chance in another way as you have a chance, you have an opportunity, something like that. Um, when we think about the word random, um, that maybe has the connotation of something more spontaneous. something chaotic. A term like luck, this is something where we talk about maybe someone is lucky. It has the idea almost that there's a force acting on your behalf. Or maybe just a large bunch of coincidences came together for your benefit, something like that. And lastly, if we talk about, um, if someone mentions having fortune on their side, there's kind of this idea behind a predestination. So kind of um, an orderliness that is designed by some external force for your benefit. Um, okay, so some of the other, I guess, historical matters with probability. So one is coming from the Italian mathematician Cardano in the 1500s. And the idea from Cardano with probability is that we're going to conduct some experiment. We have a collection of possible outcomes, and outcome is um, when each of our outcomes is equally likely, we can say that an event that occurs with m possible outcomes occurs with probability m divided by n, where n is our total number of outcomes. So, for example, suppose that we want to ask what is the probability of drawing a spade from a deck of 52 cards? We shuffle our deck, we draw out a card, uh, we have 52 possible outcomes, and the probability of drawing any one card um, is the exact same as drawing any other card. So in that case, what we would have is we would have 13 ways to draw a spade. We would have 52 possibilities, so it would be 1 in 4. Or maybe the probability of drawing a face card, so a jack, a queen, a king. There are three um, three face cards in each suit, in each of the 4 suits, so there are 12 face cards. There are 52 total cards, so the probability of drawing a face card would be 12 out of 52. Right? So kind of a standard way of thinking about probabilities. And here the way the probability is determined is it's all tied to conducting an experiment. Okay, so statistics goes back quite far in history, really. So some of the earliest places that history shows up is in censuses. So the counting of populations. And what we see is we see this showing up in ancient Egypt. We see this occurring also in ancient Babylon. And biblically, where we see this occurring with the Israelites just after they leave Egypt, after they cross the Red Sea, one of the first things that occurs is there's a census at the beginning of Numbers. And then after the Israelites wander through the wilderness for 40 years, we see that Numbers also finishes with another census as the Israelites prepare to enter the land of Canaan. And this is some of the earliest recorded statistics that we actually have. Um, Similarly, areas where probability show up is maybe not unsurprisingly in gambling. So there is known objects that were used as dice in ancient Egypt that would have been used for gambling purposes. So there's already this interest in chance, in probability, going very far back in human history. Okay, so some of the earliest philosophers, I guess we could say, on the nature of probability would be Aristotle, the Greek philosopher, and then Augustine of Hippo. I believe Augustine was 3rd century. So for Aristotle, the idea of chance was something that was unpredictable. It was something that we couldn't really say that much about. It was very uncertain. And what that means is that it's not really something that we can develop any kind of theoretical aspects for. So this is somewhat of a problem for maybe Aristotle's Greek counterparts, because if if probability or chance, or however you'd want to refer to it, is something that has no orderliness to it, you can't really do anything with it mathematically, because you need a lot of order for mathematics to apply. For Augustine, chance was something that, um, well, simply it didn't exist, but it was a part of the will of God. So you could think about it as, in the book of Jonah, when Jonah is on the ship and the shipmates are all um, going to cast lots. To Aristotle, or no, sorry, not to Aristotle, to Augustine, the casting of the lots is something that has a predetermined outcome by God. To Aristotle, um, the casting of the lots would be completely arbitrary. The lot could have fallen on Jonah, the lot could have fallen on anyone else on the ship. So we have these two kind of conflicting views in kind of the early origins of probability. And then, um, just as another um, point on censuses, we see censuses showing up all throughout the ancient world. So we see them showing up in ancient Greece, and then also, very famously, we see them in Rome. So one example of that is the census that Luke makes note of um, in Luke 2. And then we can talk about some of the more modern developments in statistics. So we have mortality tables coming from England in the 1600s that would be very useful to kind of lay a lot of the very early groundwork in statistics. In the 1800s, we really see the first development of statistics as an academic discipline. Um, Prior to that, there wasn't kind of this formalized discipline of statistics going on. Okay, so one of the first parts that becomes very important is this conversation between the mathematicians Blaise Pascal and Fermat, and this dividing the stakes game. So the conversation between Pascal and Fermat was about this theoretical setup. So we have two participants. They put in um, they put in an equal amount of money into some pot, and they proceed in some series of games where whoever gets to a fixed number of wins first takes the pot. So you could imagine it as something like um, um, whoever can hit 10 free throws first in basketball or something, or whoever could hit 30 bullseyes first wins the pot. But the twist that they put into the game was that at some point in the procedure, the participants have to stop. So maybe um, there's inclement weather, um, it gets too dark, something like that, and the participants have to stop and they can't continue. And the question is, how do you divide up the pot? So maybe it's a first to 10 match, and it gets stopped when one of the participants has 3 wins, the other one has 1 win. Or maybe one of the participants has 8 wins, the other one has 6. How do you divide the pot? Um, so this is something that we'll we'll come back to, and we'll give a couple of potential answers um, to how we divide the stakes in this case. Okay, and then a couple of years after that, in 1657, Huygens goes and publishes the first textbook on probability. So this was Calculations in Games of Chance. So this, so same kind of idea. One of the main origins for probability, or chance as it was really referred to back then, was all around gambling and these kind of ideas. Okay, so, in 1662, there were a handful of interesting developments. So one is that there was Pascal formalized what's now known as Pascal's wager. So Pascal's wager goes and analyzes two possibilities and two ways of acting. So when Pascal was thinking about belief in God and whether or not it's profitable, there are two possibilities. Either God exists or God does not exist. And there are also two ways of acting. You can either act as if God exists or you can act as if God does not exist. So in total, there are four possibilities. You act as if God exists and God does exist. You act as if God does exist and God does not exist. You act as if God does not exist when God does exist, or you act as if God does not exist when God does not exist. And from the wager, we can just analyze the outcome from each of these four possibilities. So Pascal's way of thinking was that if you act as if God exists and God does exist, then that's a good thing for you. Um, if you act as if God does exist when he doesn't exist, there's not really any harm done to you. If you um, act as if God does not exist and God does not exist, that doesn't really matter because God doesn't exist. But then lastly, if you act as if God does not exist, but God does exist, then that's not a very good outcome for you. So on the basis of this reasoning, um, Pascal's conclusion was that you should just act as if God does exist, because the harm done is minimal if you're wrong. Also around the same time, the German mathematician Leibniz was considering probability as it applied to legal or ethical questions. So one problem that Leibniz was thinking about was what action should you take based upon not only the outcome that your action will bring, but also the probability that your action is successful. So Leibniz would look um, at a situation where you have two choices. You can only choose one. So you have action A, you have action B. And what Leibniz proposed was that, well, let's say that in action A, it's if you attempt to undertake action A, and we have a scale of goodness of 4 out of 10. Action A is successful um, 6 times, no, let's say 7 times out of 10. But action B is successful only 3 times out of 10. But if it is successful, it will give you, we'll say, on a scale of goodness, 9 out of 10. Well, to Leibniz, the way you would go and resolve this, which action to choose, is you would multiply the two numbers together. So you would have a 4 and a 7 for action A, which would give you a 28. And for action B, you would have a 3 times a 9 for 27. So what that would say to Leibniz is, well, because the 4 times 7 is greater than the 3 times 9, you should undertake action A, even though the outcome that you'll gain from it isn't as good as action B if action B was successful. One of the other things that Leibniz did in a correspondence um, with another notorious or I guess famous mathematician, Jacob Bernoulli, was they would go and discuss the nature of um, of being able to draw conclusions. So suppose they, so what they would do is they would say maybe um, we're going to go and conduct a sequence of experiments, and we'll conduct 100, maybe 1,000 experiments, and what we want to see is some probability. So maybe it would be the probability of um, something involving death. So maybe we have 1,000 patients with some disease. We see some number die. That gives us a probability of dying from the disease. Or maybe we throw a die, something like we throw a die and we see how many times we get a 2. And that gives us the probability of how many, of drawing a 2. To Bernoulli, his perspective was that we can take eventually enough experiments and that will give us the exact probability. So we could take maybe 50,000 people that all have some disease, and we could find out that 397 die from the disease. That tells us that our probability of dying from our disease is 397 by 50,000. Um, Leibniz considered the same problem, and his perspective was that, well, we can take more and more experiments, But no matter how many experiments we take, we're always taking a finite number of experiments. And we can't go from a finite number of experiments to an exact conclusion. So we might get close. We could get something that gives us a very good estimate. So in our case, we have 397 by 50,000 deaths, or 50,000 total people, 397 deaths. That might give us a very close approximation to this probability of dying from our disease, but it doesn't necessarily give us the exact probability. Then also in 1662, we have the first set of inferential statistics that were getting made from English mortality tables. So what was occurring here was we had John Graunt, who was actually a haberdasher by trade. So haberdasher is, um, I guess, somewhat of an old word uh, to refer to more of maybe a tailor, a yeah, hat maker as well. Um, but he went and gave some very interesting revelations. So what Grant wanted to do was come up with the probability that a person would get from one age to some later age. So for example, the probability of getting to the age of 6. And what he would do is just look through kind of the medieval equivalent of obituaries and came to these conclusions based on all of the data that he had. So if you had 100 infants, Grant's mortality table would tell us that 64 would reach the age of 6, or about two-thirds of them would get to the age of 6. And then if you have, then from there you have 64 6-year-olds, and 40 of them would get to the age of 16, so about two-thirds. Again, so still not great. And then of the 40 16-year-olds, 25 would get to 26, and so on down the list. Okay, and for this, Grant is considered the father of demography, so the practice of writing statistics about populations. Okay, so about 25 years later, we get the law of large numbers coming from Bernoulli, and this is um, one of the really fundamental rules for statistics. So returning to the idea of the conversation between Bernoulli and Leibniz, as you take more and more people who have some disease, for example, and you keep evaluating the proportion that die from this disease, as you get more and more people that have the disease, it gives you a better and better estimate of the actual mortality rate from the disease. Okay, and then around the end of the 1700s or so, the French mathematician Laplace substituted the word probability in for chance. So, kind of as I'd said at the beginning, probability has more of this connotation of order, chance more the connotation of disorder. And on the matter of chance, there's maybe a relevant quotation from also a French mathematician, Abraham de Moivre. So what de Moivre said was that chance as we understand it supposes the existence of things and their general known properties. Then a number of dice, for instance, being thrown, each of them shall settle upon one or the other of its bases, so you throw a die, it comes up on some side. After which, the probability of an assigned chance that is of some particular disposition of the die becomes as proper a subject of investigation as any other quantity or ratio can be. Um, so in other words, you throw the die a bunch of times and you come up with an understanding of how likely it is that each face comes up. But chance, in atheistical writings or discourse, is a sound utterly insignificant. It imports no determination to any mode of existence, nor indeed to existence itself, more than to non-existence. It can neither be defined nor understood, nor can any proposition concerning it be either affirmed or denied, excepting this one, that it is a mere word. So this kind of suggests why Laplace wanted to move away from the idea of chance to this idea of probability. So what de Moivre is saying is that chance is just a word. It doesn't really say anything. It's not a force. Chance isn't acting. It's not doing anything. And we can't really understand it very well. And to move into this idea of having a discipline of statistics or a discipline of probability we'd want to have something that's very orderly, that we can kind of understand. And this is where the switch in terminology comes from. Okay, and then about 200 years later, we get Sir Francis Galton giving us the central limit theorem. So we'll come back to the central limit theorem in a few weeks after we've developed some of the terms, but it's also an idea that as we take more and more um, samples, we hone in on a true value. Okay. Then as we move into the not so distant past in the 1900s, one of the developments that we get is the uncertainty principle, which tells us that we can't predict the position and velocity of an electron simultaneously. And when we're trying to predict the position of an electron, we just get a probability distribution of where our electron is going to be. And then when talking about developments in quantum theory, what we get is that we can take um, probabilities of what's going on at the microscopic level, at the atomic level, and we can use that to get fairly good probabilities of what's going to occur at the macroscopic level. And the idea behind this is kind of coming out of the law of large numbers. So as we take a lot of experiments, we take a lot of samples, we can get fairly good idea of what's going to happen after we've taken a lot of experiments. Okay, and then one of the very well-known philosophical statements is coming from Einstein with the statement that God does not play dice. So the idea that um, God's not leaving the occurrences in the world up to happenstance, we'll say. Okay, then to wrap up this discussion on philosophy and history of statistics, I just want to read a couple of Bible verses to see what we can take away biblically. So the first verse, or first couple of verses that I have, is Romans 11:33 through 36. Oh, the depth of the riches of the wisdom and knowledge of God! How unsearchable his judgments, and his paths beyond tracing out! Who has known the mind of the Lord, or who has been his counselor? Who has ever given to God that God should repay him? For from him, and through him, and to him are all things. To him be the glory forever. Amen. So from Paul in Romans, we get the idea of um, God instantiating a very orderly creation. Okay. In Isaiah 45:12, Isaiah writes, I made the earth and created man on it. It was my hand that stretched out the heavens, and I commanded all their hosts. So again, um, the idea that we're seeing is that God is behind the created order, and it's not something chaotic. It's something planned out. It's something designed with purpose. Jeremiah writes in Jeremiah 33:25, Thus says the Lord, if I have not established my covenant with day and night and fixed order of heaven and earth, then I will reject the offspring of Jacob and David my servant, and will not choose one of his offspring to rule over the offspring of Abraham, Isaac, and Jacob. For I will restore their fortunes and will have mercy upon them. And the idea that we see in Jeremiah 33:25 is very similar to this idea from both Romans and Isaiah. It's that God is creating and establishing a fixed order, in this case, a fixed order between the day and night, the heavens and the earth, and that it's God sustaining it. In 1 Corinthians 14, Paul writes in verse 33 that God is a God um, of peace and not of confusion. So again, we don't live in a world that is chaotic, unplanned, and left up to arbitrary happenstance. It's a world where God is in control and clearly in control. Okay. In Proverbs 16:33, Solomon writes for us that the lot is cast into the lap, and its every decision is from the Lord. So very much, this is kind of the idea that would inspire the position that Augustine came to, which is that back to the story of Jonah, when the lots were cast, it was God who was determining the outcome, and this is also kind of um, a verse that could be taken as an underlying motivation for Einstein with his position that God does not play dice. So again, what to us appears to be arbitrary or um, not something that we could know is something that's being clearly planned out by God ahead of time. Okay, and then the last one. So Psalm 139, verses 13 through 16. For you formed my inward parts, you knitted me together in my mother's womb. I praise you and am fearfully and wonderfully made. Wonderful are your works, my soul knows it well. My frame was not hidden from you when I was being made in secret, intricately woven in the depths of the earth. Your eyes saw my unformed substance. In your book were written every one of them, the days that were formed for me, when as yet there was none of them. So, again, the common theme that we're seeing through all of uh, these verses is that the world we live in is something that's very orderly and it's structured by God. And what's really nice about this for um, for us, as far as we're concerned, is that it allows us to study something. It allows us to go and study what's going on. So to think about it in a simple example with a dice roll, suppose that we throw a die. We figure that the three face will come up 1/6 of the time. If we throw a die 600 times, we would expect three to come up 100 times. If we lived in a world of complete chaos where there was no orderliness, we wouldn't. The ability to study these kind of um, these phenomena wouldn't really exist. We could throw the die 300 times, and I don't know, maybe a three comes up 100 times, maybe it comes up 550 times, maybe it comes up two times. But what we'll see when we investigate the law of large numbers, central limit theorem, those kind of ideas, is that as we take more and more of these experiments, we can make somewhat firm conclusions on the outcomes. Um, and we can take this from this orderliness of the created order that we get directly from God. Okay, and then the last thing that I want to do, just in closing, is I just want to give kind of a brief introduction to R and some of the things we can do with it. So we can open R up and just start running a couple of commands. So we add things together, 2 plus 3, we can subtract 4 minus 2, we can multiply together with the star operation, 5 times 8 for 40, and we can divide things 9 by 3. And then what R also allows us to do is go and start making some fairly rudimentary simulations. So what I'm going to do is I'm going to take a vector. So I'm going to say there are two options here, heads and tails in my vector. So I would get something that looks like this. First option is heads, second option is tails. And what I'm going to go and do is assign it to the variable outcomes. I'm going to make outcomes and assign this vector where my first entry is heads, my second entry is tails, into outcomes. And I do an assignment with the less than arrow and a dash. So it makes a little arrow. One thing to keep in mind is that case does matter, spelling matters here. So if we did outcomes that was all capitalized, our variable wouldn't be known. Okay, and then what we can do is we can what's called sample from our possible outcomes. So I will take a sample of my outcomes, so conduct coin flips, and I'll take 200 of them. And in this case, what we wind up with, if I go and convert my results to a table, is 109 heads, 91 tails. So what X is just a listing of all of the outcomes. So X, the first coin flip that we got was a tails, the second one was a heads, the third was a tails, the fourth was a tails, the fifth was a tails, 6 was heads, 7 was tails, 8 was tails, and so on. And what table does is it just collapses all those down. It counts the number of heads, counts the number of tails, tells us that. Okay, we could do this again. And we could take a table of another draw of 200 coin flips. This time we get 110 heads, 90 tails. Let's see, we could do it a third time. And now we get 104 heads, 96 tails. So again, kind of in that neighborhood of 50 heads, or 50% heads, 50% tails. And if we really, really wanted, we could also just go and increase the number of draws. So we can make it 200,000 coin flips that we're going to do. Oops. There. If we call 200,000 coin flips, in this case, we get 99,848 heads, 100,000, 156 tails. So again, kind of in that neighborhood of 50-50 heads and tails, and as we get more and more coin flips, that number gets kind of hones in on 50% heads, 50% tails. Okay, and then the last thing that I'm just going to go and do is give a plot of these results. In R, you can go and import certain packages. One of them is ggplot, so that goes and gives us a library for just calling plots. From here, I'm just going to call the ggplot function, so I'm going to plot Z. I'm going to plot my data. I'll plot Z. Okay. And what we see here from Z, so remember that when we had the draw in Z, there were 104 heads, 96 tails, and we just get this nice histogram plot, 104 heads, 96 tails. Okay, so this gives us a quick introduction to what we can do in R. What I'll do is I'll go and I'll put a couple of just sample exercises that you could do in R with a couple of these commands just so you can get some practice using it. I'll probably go and pull out R again for a little bit in next week's video, and I will see you all then.